Good day, everyone. Today I'll be talking to you about the basics of modern geometry. So it is a very basic topic, yet very important before proceeding to deeper concepts of modern geometry. So today I'll be talking to you about segments, rays, angles, and triangles. So let's start. Segments, rays, angles, and triangles. So first we'll tackle about segments. So segments starts with a point. So in this case, this is point A. Points are named with capital letters. So when two points are connected with a straight line, so we get a line segment. So that is how we form line segments, connecting two individual points with a straight line, and we have a line segment. So in this case, point A is connected to point B, and we have a line segment AB. We denote a line segment by writing AB, putting a bar above the letters. Another example, point C is connected with point D, and we would indicate the above line segment by writing CD and a bar above the letters. That is line segment. So where can we see line segments? So sides of a triangle are line segments. And also in a line we can also form a line segment by just removing the arrowheads, and the remaining will be a line segment. So a line has no beginning point or end point. Imagine it continuing indefinitely in both directions. So in this case, we have line EF. So we denote a line by writing EF and then line symbol above the letters. So that is about segments. Basic concepts about segments. Next is about array. So array starts out at a point and continues off to infinity. So we can say that array is the half or one half of a line. Okay? So it starts at a point and then extends infinitely. So think of the sun's rays. They start at the sun and go on infinitely on the universe. So we have here some images about rays. This is a ray, start at a point and extend infinitely. This is the sun with its rays. Next, so we can name a ray using its starting point and one other point that is on the ray. So that is, in this case, we have ray QP. We'll name it starting at the starting point Q, and then any point on the ray. In this case, we have P. And we can also name a ray using a lowercase letter. In this case, we have letter R. So consider the two parts of array. So note that a pair of points, okay, Q and P determines at least 6 geometric figures. So 2 points can form many figures, not only line, not only segment, but 6 geometric figures. First, connecting QP, we can form a line QP. First. Second, the segment QP here, connecting points Q and P. Next, we can form the ray QP, okay, connecting points Q and P and extends right infinitely. And also, fourth, the ray opposite to QP. So the ray opposite to QP will start at Q and then extends left infinitely. Then fifth, the ray PQ, so the opposite of QP, the starting point will now be at P, then extends through Q and left infinitely. So that is the ray PQ. And lastly, the ray opposite to PQ. Okay, so the starting point is at P but extends right infinitely. So those are the geometric figures that can be formed out of 2 points Q and P. The line QP, segment QP, the ray QP, the ray opposite to QP, the ray PQ, and the ray opposite to PQ. So that's all about rays. We'll now proceed to angle. Okay, so we are finished with segments, rays. Now we'll proceed to angle. So many people think that an angle is some kind of slanted line, but in geometry, an angle is made up of two rays that have same beginning point. So the figure here, this is an angle. An angle is made up of two rays, and the the common beginning point is what we call the vertex of the angle. And the two rays are called the sides of the angle. So to name an angle, we use 3 points. Now we use the 3 points, listing the vertex in the middle. So the vertex must be in the middle. So in this case, we'll name it as angle DEF, or we can also name an angle through its vertex alone. So in this case, we can also name it as angle E. So you can see here there are 3 angles. First is a 360-degree angle. So when the angle opens up to full circle, so we say that the angle is 360 degrees. Okay, so when the angle opens up to half circle, so we call it a straight angle measuring 180 degrees. And this third one is 1/4 of a circle and half of a straight angle. This is what we call the right angle, measuring 90 degrees. Okay, next. Okay, we can see here an angle with a measure of 135 degrees. It is an angle greater than a right angle but less than a straight angle, and we can call it obtuse angles. An angle that is more than a right angle yet less than a straight angle is what we call a obtuse angle. So in the right side we have 3 angles. So from the right to left, increasing measures, but they are all less than 90 degrees, and we call them acute angles, which means that they are less than a right angle. Okay, so if more than a 90 degrees but less than a straight angle, we can call it an obtuse angle. But if they're all less than a right angle, then we can call them acute angles. Okay, very basic. So here's another way of thinking about angles. So imagine in the morning, as the sun rises in the horizon. So as the sun rises in the horizon early in the morning, so the angle from the ground to your line of vision to the sun is zero angle right there. But if the sun rises in the morning, in the mid-morning, at about 10 o'clock, okay, it forms an acute angle. In the noon, it forms a right angle. In the afternoon, it forms an obtuse angle. And in the evening, right there, it forms a straight angle, 180 degrees. So this is one of real life situations where we can see angles, and there are a lot more in our everyday life, everything that we encounter. Okay, so that's all about angles. Now let's move on to triangles. So I think this is the last concept that I'll be talking to you about, triangles. So a triangle is a closed figure made up of 3 line segments. So this is perhaps the first definition I learned about triangle way back in my elementary days. So a triangle is a closed figure made up of 3 line segments. So right there, triangle ABC. So there are types of triangles based on sides. First is an equilateral triangle. A triangle having all the 3 sides of equal length is an equilateral triangle. So right there in this case, we have a triangle with both sides, all sides measuring 2 centimeters. This is what we call an equilateral triangle. Second is an isosceles triangle. So if an equilateral triangle, all sides are equal, have the same measures. In an isosceles triangle, only 2 sides have equal lengths. That's what we call an isosceles triangle. Very basic. And the third one and the last one is an scalene triangle. So if equilateral has 3 sides have the same length, isosceles 2 sides of the same length, scalene triangle has no sides with equal lengths. So scalene 3 sides, isosceles 2 sides, scalene no sides of equal length. So those are the 3 types of triangles based on sides. Now we'll proceed to types of triangles based on angles. First is an acute angled triangle. So from its name, a triangle whose all angles are acute. Okay, so if all the angles of a triangle are all acute angle, meaning less than 90 degrees, then we can call it an acute angled triangle. Second one is an obtuse angled triangle. It's indicated in the name, obtuse angled. If there is one angle in the triangle that is the measure is more than 90 degrees, but less than a right angle, a straight angle, then we can call it as obtuse angled triangle. There's the second. And the third one and the last one is the right angled triangle. So a triangle whose one angle is a right angle is a right angled triangle, a right triangle. Okay, so in this case you have there angle A at 90 degrees. So this is a right triangle, a right angled triangle. So if we have a right triangle, we can always use Pythagorean theorem to find missing lengths. Okay, so we can only apply Pythagorean theorem in right angles, right triangles. So here, as a summary of triangles, there are types of triangles based on sides and types of triangles based on angles. So based on sides, you have equilateral, isosceles, scalene, and based on angles, you have acute angled, obtuse angled, and right angled. So under right angled, we have special right triangles, 45, 45, 90 triangles, and 30, 60, 90 triangles. So we'll talk more about that special triangles in the next slide. Okay, so there are different types of right triangles. As of now, our focus is only on a special pair of right triangles, the 45-45-90 triangle and the 30-60-90 triangle. So 45-45-90 triangle, from its name, its two angles measures 45 degrees and the other one is 90 degrees, totaling to 180 degrees. And this is an isosceles right triangle. So look at the figure. Since this is an isosceles triangle, two sides must have the same measure. So using the Pythagorean theorem, we compute the hypotenuse using the Pythagorean theorem. C squared is equal to a squared plus b squared, and we can get square root of 2. Second type is the 30-60-90 triangle. So from the name itself, one angle measures 30 degrees, the second angle measures 60 degrees, and the third angle the 90-degree angle. So this is a scaled triangle. No angles or sides of common length. So in this 30-60-90 triangle, the ratio, at the sides has the ratio of 1, square root of 3, and 2. Why? So look at the figure. The shortest side in a 30-60-90 triangle, the length of the shortest side is half of the longest side. So if we'll use Pythagorean theorem, manipulate the formula, we can get the square root of 3. Okay, so there's the two special type of right triangles, the 45-45-90 and 30-60-90 triangle. Okay, so after discussing all those triangles, let's take some time to discuss some basic properties of triangles. So first, the sum of the angles in a triangle is 180 degrees. And that is always true. We all know that since elementary, that the sum of the angles of a triangle is 180 degrees. So this is called the angle sum property. Okay? The sum of the lengths of any two sides of a triangle is greater than the length of the third side. Similarly, the difference between the lengths of any two sides of a triangle is less than the length of the third side. So, if you're given only measures of sides and you're not given the triangle, you can always check if the measures comprises or forms a triangle using this property. Next property, okay, the opposite side to the largest angle is the longest side of the triangle, and the side opposite to the smallest angle is the shortest side of the triangle. So that's always true. So if larger angle, it is must be opposite to the longest side. So in the figure, angle B is the largest angle, measuring 90 degrees. It is opposite to the longest side AC. The figure, angle A is the largest angle, it is opposite to the longest side BC. It will always be true. So those are some basic properties of triangles. Now we'll talk about exterior angles. The exterior angle, so it is the angle here, angle ACD. Okay, is the exterior angle of triangle ABC. So an exterior angle of a triangle is equal to the sum of its interior opposite angles. This is called the exterior angle property of a triangle. So we can always get the measure of this angle here by adding the measures of this angle and this angle. Okay, so angle ACD is equal to angle CAB plus angle ABC. So that is how we get the measure of any exterior angle. So that's all about exterior angles. And lastly, the area of triangle. So from elementary, we already know that the formula in getting the area of a triangle is 1/2 times base times height. So in this case, the area of this whole triangle is equal to 1/2 times PR times QS. So PR is 6 times QS is 424 times 1/2. So the area of this triangle will be 12 square units. Very basic. Again. So for a right triangle, it is easy to find the area as there is a side perpendicular to the base. So we can consider as its height. So if we have a right triangle, it is very easy to find the area of this triangle, because we don't need to look for the altitude of the triangle because it is already given. It is perpendicular to the base. So we can immediately get the area of a right triangle. So I think that would be all for the basics of modern geometry. So to sum up everything, you can try this activity, answer this activity, and we'll try to check your activity in the next video. So that would be all. I hope you learned something from the video. Thank you for watching, and God bless. Keep safe, everyone. Bye bye.